Yeah, uh, the recording has started. So welcome, Eric. We
Thank
might
you.
put it on internet. So for people like us who want to get into parallel programming.
Sure.
So yeah, so I first got introduced to you by reading your blog post on parallel programming. So that
Right.
was my first entry point. So could you tell me like how you come about that post?
How I came about the post.
Yeah.
Well, I finally got to a place in the industry where I felt like I was kind of established, and it took a while. And I thought it would have helped if somebody had been in my position and was able to kind of provide a little bit of guidance because the the documentation and the expository material that's available currently is pretty scattered and it's like kind of encyclopedic. So it can help to have somebody that kind of winnows it for you and takes what is like a big, huge document and says, like here are the sections that are relevant to read. So I think if I'd had somebody to do that for me, it would have maybe gone faster. But as it was, it went pretty long.
Yeah, so as I see, your journey was like pretty much unconventional. You had a PhD in mathematics and then you got into low-level GPU kind of things. So how
Right.
it
I
happened?
had most of a PhD. I didn't finish.
Oh, you didn't finish it.
No, I didn't finish.
Okay. So like how you got into like GPU stuff in your PhD in mathematics, or you were doing it
Yeah.
before also?
I kind of thought that I would try to see if in order to get my hacking muscles going, if I could kind of leverage some skills that I already had. And so I
Mhm.
thought, okay, numerical linear algebra makes sense to try to focus on, and there's machine learning is quite mathy. So that led me naturally to GPU programming and systems programming. And then what I found was that it does kind of play well with the mathematical way of thinking. Like it rewards kind of focused, like detail oriented approach.
So do you think like any kind of specific courses in mathematics like helped you the way you think about parallel programming? Any,
Um,
yeah.
Not really. I think the most important thing is just the kind of fastidious, very detail oriented way of thinking. Yeah, a little bit of multi-dimensional calculus where you take derivatives and things like that. But actually, that you don't learn to take derivatives in the way that you need to for a neural network sometimes when you're taking those classes. But nevertheless, it helps, and to not be afraid of what a derivative in many dimensions is, I think.
Yeah, you mean partial derivatives, right? Right.
Yeah, but yeah, in machine learning, as you may know, like there's this notion of back propagation, and I think having a mathematical background is helpful because it makes it a little bit easier to understand what's going on and why.
Yeah, but I'm sure like it doesn't take a PhD level maths to
No,
understand backprop. Yeah.
certainly not. But yeah, so I think most of the actual content of my math degree was not directly relevant in any way. Um, but yeah, it's just kind of part of me, and it's part of the way I think. So it has I've carried it with me, of course.
Yeah, got it. Like, by the way, how many years you did your PhD before dropping out?
Oh, like 4.5.
Really, you invested a lot of time there.
I really did.
Yeah. What was your favorite things in your PhD, like the courses you took or any specific thing?
Oh, which courses? Oh my gosh, so many. Well, I started out doing pure stuff, so I really loved category theory and I loved algebraic topology. Um, and I had some really good teachers there. Um, I mean, I loved it all. Analysis, abstract algebra. Um, I loved, and then when I started to take more applied classes, I loved those as well. Sort of more like algebraic, linear algebra algorithms, and um, I really love probability, um, and I love, yeah. There's just so many great things.
Yeah.
It's
From
hard to
algebraic topology, I remember algebraic geometry, I guess. Alexander Grothendieck. He was
yeah,
like godfather of it.
yeah,
Yeah.
yeah. I think if I had no programming work to do right now, and I was forced to only read math, I would probably read about concentration of measure in probability. That's something I'm really interested in, and like combinatorics. I like that a
Yeah,
lot.
like these are like foundational things also used in AI a lot.
Yeah, maybe. Yeah, to
It's
some
just your
extent.
that's how your sabbatical days would look like, doing
Yeah,
maths, just sitting there.
yeah,
Great. So I really love that in the post how you just differentiated parallel programming to specific machine learning stuff. You said it is
yes,
kind of generalizable across domains, and I kind of liked it. So
yeah.
what
I
do you
think
think like how it is generalizable, like not just AI?
Yeah, I think AI is the main application, but the sort of physics of the situation is that we if we want to keep scaling up more and more compute, we have to do it in a parallel way. So and then also the notion that instead of a human explaining all of the cases of a program, that we're going to start doing things differentiably now, where it's like you just have a model and you train it by backpropagation and stuff. I don't think that's going to go anywhere. That's the way of the future, because we want to be able to write programs that are so complex and um, leverage like big data as we continue to collect more data. So differentiable parallel programming is, I think, not not just a fad. It's here for a while, and I think the current type of AI will probably be very different in 5 years or 10 years, but we're going to need people that can either write parallel programs, or if AI starts writing our programs for us, then at least somebody that can reason about what can be done and can listen to the AI or however it works out.
So what do you think about this experiment by NVIDIA where they make an AI model optimize CUDA kernels or things like
Yeah,
that?
I mean that's great. I don't know. I think I myself use Claude Code all the time. Um, that's a little bit
That's
different
trending
from
these days, by the way.
what was that?
Cloud Code, yeah, everyone is using it.
It's great, yeah.
Yeah.
And what NVIDIA is doing is, I think, a little bit different from just that, but yeah, I think it's great.
So how much percent of your work do you think like is done by AI these days? Is it mostly grunt and repetitive work or also creative thought kind of thing?
Um, yeah, I think both in a way, but it can be currently at the current level of the performance of the model. It's like you have to be kind of a manager. Like you say, here's exactly what I want, but you can now write it in English, and then I'll say like make a draft for me, and then I'll say, well, this part of the draft doesn't make sense, but you have to redo that. But so you need to be able to reason about what's possible and what's correct, but then it frees you from doing the work of applying every single line of changing that you need to
Yeah.
do. So it's
I
great.
also feel like when you explain the stuff to an AI in a very detailed way, it also clears up your head, how you
Yeah,
think about the
absolutely.
problem. Yeah, I have
Yeah,
felt that a lot. Yeah.
definitely. And that's where I find sort of my mathematical background is a boost as well, because in math, what you learn to do is to explain exactly rigorously exactly what you mean in English, which is
Yeah.
how you like to talk to the AI as well.
Math accepts no bullshit. You have to be
Yeah,
very
exactly.
clear and defined. Yeah.
True.
You also like created content for Art of Problem Solving channel. I looked at in your LinkedIn.
Yeah, I did. I was a teacher for art of problem solving for a little while. That was great.
Does
I love
Wayne
teaching.
who runs that channel? I think he worked with Grant Sanderson, Three Blue, One Brown.
Oh no,
Uh,
yeah, Art of Problem Solving is a company. I think they're based in San Diego. Um, yeah, it's just an American company that does kind of like after school teaching for kids and stuff, but it's all online, which is kind of interesting.
oh, that one. I thought there is a specific channel on YouTube called Art of Problem Solving. I thought you created content for
Oh
that.
no, this is a company that I worked for a little while.
Okay, so that
Yeah,
might be a confusion. Like
yeah.
Grant Sanderson, Three Blue, One Brown, and two other guy used to run that. As far as I remember, not.
Oh, interesting. Okay. Yeah, I love Grant Sanderson. His videos are great.
Yeah, recently they released a video on diffusion models yesterday, I think.
Oh, he did. I got to check that
Yeah,
out.
actually he invited Welch Labs, a guest video. He's on kind of a sabbatical. He's not going to come, so he's collaborating with other guests. We're
Oh,
creating
cool.
content on Manning. Yeah.
I'm gonna look it up right now.
Yeah. A
I don't
30,
know too
40
much
minute
about
video, I
software.
guess. Very detailed one.
Cool. Oh,
Did you
here it
find
is.
it?
Yeah, I did.
Yeah.
I like the graphics that he with his library that he creates. They're so
I
good.
love the fact that he created that library to create the graphic himself, because
Absolutely.
nothing was there. Now it is sort of got many stars on GitHub. Many creators are using it, so that's great.
Yeah, it's great.
Yeah. So, like, what advice would you give for people like me who are getting started on parallel programming, writing simple CUDA kernels for vector addition, matmults, and stuff? What
Yeah.
do you think about it? I read about this book, Programming Massively Parallel Processors, and that is intimidating, man. That's such a big book, so many
Yeah.
exercises. Yeah. So,
And the unfortunate thing is most of that book is not particularly useful for warming up to have your career in this field. It's not that it's a bad book. I think it's a good effort, but the field is just moving so fast, and that book does tell you some things like how to think about the domain in a bit, but it's not quite enough. And so in response to your question, I would say email me and ask me questions as you go, and just ask me like, is
yeah,
this useful? Is this, because there's really no substitute, because there's no textbook. I wouldn't recommend somebody start reading through PMPP. It's just too much, and there's not enough of it is relevant. What one really needs to do is to develop the sort of courage to go through the primary documentation, which is like the PTX manual, the CUDA C++ programming guide, and other things like that, and to not be afraid of it, to be able to like confront those complicated ideas, but also to learn for yourself, like, this is the part that I need, and then I can leave all the rest of this behind. But it's hard because there's like a circular dependency. In order to know what is useful, you have to already have some kind of a background. But in order to get
yeah.
that background, you have to be able to grab enough stuff to know what's useful. That's what I try to help people do, is kind of break that circular dependency.
So you basically vouch for this top-down way of learning, where you just want to do something and then you learn the things related to that, rather than going from bottoms up where you are intimidated by theory.
Yeah. So I think having some kind of a mentor or somebody to bounce things off of is important. And then even if you're not doing a project that you would necessarily show to a company, or just have some project to start with, because it can help you decide, at least at the beginning, what to learn and what not to learn, which is important because there's so much and it's just like encyclopedic. So you can ask yourself, like, is this page or this website or this API needed for my project? And that can be something that at least you can decide. But it's like, at first you don't know what's useful, so maybe it's just makes things a little more concrete.
Yeah, like what was your approach? Like, did you dive into theory first? Like, you got into this?
Yeah, I was interested in this library Cutlass from the NVIDIA team, and I hung around in this Discord called GPU Mode. So it was kind of like being around people who were learning and like listening to what they were up to. And I gave a talk there, and it forced me to kind of learn about the library. And it turned out to be a lucky thing to choose to learn about first, because it's kind of an important library in the ecosystem. It's not just kind of on the side, like, it's very central. So yeah, I think there's a lot of ways to go about it, and it depends on one's learning style. But yeah, just keep trying, and when I talk to people that are learning, I always try to steer them towards like, get into the habit of writing some code. Don't do everything with Colab. There's nothing wrong with Colab, but just like try to do things from the command line. Try to write your own C++ and get used to the compiler errors. Work in a Docker container, because that's what you'll have to do when you get a job in the industry. And just kind of get your reps in, get the mistakes out of the way, and just start early and just keep going.
What was the library you talked about and what it does?
Oh, Cutlass, Cutlass,
Acha,
and that's
CUT, yeah, it's Cubeless, like analog to that.
yes, they're both
Yeah,
from NVIDIA. Kublas is of the nature that you take essentially like a wide selection of kernels or binaries that they've already made for you, and you can pick one to run, and it does different things. Cutlass is actually like way more flexible, so you can write your own low-level linear algebra kernels, and it can, at first it can be a little bit forbidding because there's just a lot to learn about it. But it's just like the ultimate tool for learning to use the NVIDIA hardware to its like full potential and with anything you want to do, basically.
Like, does it give an interface to like tweak the PTX layer of the CUDA or just CUDA only?
Yeah, it's a layer on top of PTX, and it hopes to make it, more kind of robust abstractions than just the actual PTX. So they have a whole kind of tiered system of like layers of abstraction. Some of it is host code, some of it is device code, and it's great. I love it. And then there's another thing that my company together is pushing right now, which is this library called Thunder Kittens. You can think of it as kind of like something on the similar layer to Cutlass, but with a different design philosophy. So that's another thing in the ecosystem that's interesting.
Like, that's also a NVIDIA native only.
No, Thunder Kittens is actually written as an academic project originally, and now our company is kind of pushing it as a company-wide thing for kernels to be written in this framework. We're hoping that it's a bit easier for people to onboard and to learn this library than Cutlass, which has a reputation of being pretty difficult.
So whatever you said, I interpret this Cutlass gives a more fine-grained control over writing your own like linear algebraic operations.
Yeah, that's absolutely right.
Like, what are your thoughts on AMD? We talked about it on chat. Like, did you play around with it a little bit?
Yeah, I know. I want to. I have not gotten a chance to do any of the AMD coding yet. Have you done it?
No, like I'm seeing it trending. Like people are saying their GPUs are becoming very good these days.
Yeah, that's
Yeah.
the hope anyway. I don't know for sure. I wish I had more experience in that.
Yeah, they're saying like they have made their programming framework like open source, unlike CUDA. So maybe
That's
that will
great.
help them in long term. I don't know.
Yeah, I hope so too.
Yeah. So, Terry, what are the 3, 4 projects of your mind would you recommend to a beginner to try?
Yeah, so
Yeah.
I would probably want to have it more be a conversation between me and somebody, because there's not like, I think if you're doing like data science or something like that, there are like very common, well-trodden projects that you can kind of warm up on. I don't know any of those for GPU programming. I mean, you can try to write some various reduction kernels and do like a tree reduction and stuff like that, and that's great. But yeah, I think to just recommend that as the default doesn't seem quite right to me. It seems like I'd want to talk about what are you interested, where do you want to go, what do you already know. Somebody that I would maybe difference between somebody that has a lot of math background already and somebody that doesn't, or machine learning background. So there's different things for different people. I think it's context.
I feel like you would have sufficient confidence when you simulate fluid dynamics on a GPU.
When you see what?
When you simulate fluid dynamics, Navier-Stokes kind of thing.
Wow, that's an interesting project. People are doing this, I think, right?
Yeah, yeah. That's not for beginner, I guess. Yeah.
Yeah, that seems pretty advanced. I actually don't even know how one would do that, but it sounds cool.
What are your thoughts on like how a beginner like me, let's say, or anyone else who is getting into parallel programming would use LLMs to generate code or to ask
Oh
more
yeah.
questions about it?
Well,
What do you
if you
think?
can, if there are free ones, obviously, but if you can afford it, I think it's absolutely crucial to use the best models like O3 Pro and O3 as learning tools, because, well, as you say, they can write code for you, but that's maybe not the primary thing. I think the primary thing is like just to learn and have a sort of a dialogue with them, and to kind of have a conversational style of learning. Like, what is this? Well, how can I understand this concept better? What's a reference for this? And just keep asking. And the process of generating crisp questions, I think, is a great discipline as you keep learning, because until you write out, like you were saying before, until you write out the question in a very specific way, sometimes you don't even know what it is you're trying to find out. But yeah, I'm all about the AI tools for learning. And sometimes it can help you write the boilerplate, which can be hard at first.
In context of using AI, I also feel like asking the right kind of questions is always the limiting factor. It's
Yeah.
not much about the models.
Yeah.
Yeah. And also
Although I
like
do find that the best models can give a lot better answers with respect to very like rigorous C++, like they seem to be able to reason better about like some of the edge cases and some of the. So yeah, I like the best models when you can get them.
Yeah, just keep asking the right kind of questions and going to the very crux of things rather than
Yes.
just generating code and running it and being happy that my code did ran.
Right. And there's nothing wrong with that sometimes, but I think if you're going to gain skill and gain competence, then you need to be doing a little more.
Yeah. So any books you are reading right now, Eric? Like
Oh, you mean about
not
CUDA or just
technical.
any books?
No, not technical, any book.
Oh, well, yeah. So I'm reading this history of World War II by Richard Evans. So it's about Germany in World War II, the Nazi regime. So this is book 2 of 3. It's called The Third Reich in Power.
Wow.
Kind of some dark subject matter, but it's very well written and good. I'm reading a lot of great books right now. I'm really excited to get to read them more. How about you? Are you reading anything?
Yeah, I'm reading this book by Werner Heisenberg, Physics and Philosophy.
Oh, cool. How's that
Yeah,
one?
Heisenberg actually wrote this book. I started reading it like in the last 2 3 days only. Not gone much into it. So, but it really is. It hooks you up in the first chapter itself.
Really?
Yeah,
Well,
you
that's great.
should
I'll
try
have to
it
check.
out. Yeah.
That's
And
cool. Did you take some
the
physics in school or?
No, no, I'm just interested. I studied physics till only high school. My undergrad was in computer science, but I just want to read. The
Yeah.
fascinating part of that was it was written by Heisenberg himself. So I thought of reading this.
Yeah, I don't know much about his history, but yeah, he seems like an interesting guy.
Yeah, he's like a lead guy in quantum mechanics. So
Yeah.
yeah.
Cool. Well, so
So
do you want to start, maybe talking more and being chatting and engaging in some learning stuff and being like, here's what I'm doing, and that
yeah,
would be fun
of
for you
course. I would
guys.
love to. I would love to.
That'd be great.
Yeah, it would be much. I'll be very much fortunate if you can mentor me around my
Yeah, of
projects and
course. Yeah, I
stuff.
mean, just
Yeah,
we got each other's WhatsApp, so just
yeah.
let me know whatever you're thinking about. If you have questions, and ask anytime.
Actually, I read your post on Hacker News, I guess. That was trending on Hacker News.
Oh, really? Which one? Oh, it was
Yeah,
trending on Hacker
yeah,
News. That's cool.
yeah. From there, I got your post. I read it in the lunchtime in my office, and then I thought of like
Oh,
throwing up
that's
a mail.
cool.
Yeah,
I never even knew it got on Hacker News. That's really cool.
yeah.
That's flattering.
Yeah. You didn't even know. I thought that you must
No,
know
I never
about
knew.
it. Okay, great. So, just curious about your role. Like, you describe your role as a researcher in Together. Like, what your works is around. Like, what you
Yeah.
around
So,
what on.
what in our company, we're called the kernels team, and that's people that write GPU code, and we're about 15 people now. And interestingly, so even though it's very much an engineering discipline, we are not on the team that's called engineering. We're on the division that's called research. So we kind of work in tandem with the ML researchers at the company, and our company is kind of like predicated on we want to be very good at the sort of synergy between good GPU code writing and like good research. So we're a lot of systems people, and we talk with the research team about like what kernels are needed for new projects and serving open source models faster and more efficiently. And then we kind of talk about like, excuse me, is this going to take too long? Is this kernel that you guys want even possible? Maybe there is already such a kernel in the open source ecosystem and we don't have to go write it. Maybe it will take 2 weeks and that'll be great, but maybe it would take 6 months and then that's not going to work. So yeah, we really work closely with the research team, which is fun for me because I get to kind of keep learning about new models and I don't just keep doing the same thing over and over again. But also I like to be I like to get low level and get focused. And so it's nice that I don't have to be I'm able to do that. Like I'm able to have the role where I can like write a kernel from start to finish and not have like 50 other things going on at the same time.
Like these big inference providers, like Together, like do they optimize a model for a specific GPU they're running on? Like let's say
Yeah.
A100 or H100. Do they do that?
Yeah. So H100 and Blackwell are the two ones that we work with a lot, and yeah, we try to be cutting edge. And when a new architecture comes out, like from DeepSeek or something like this, we try to adopt it and use it, and just use our own kind of algorithmic innovations to serve faster.
Yeah, so like if you have this thought experiment, let's say you have a model that is running in the most optimized way you ever can on, let's say, H100, and you want to put it to B100 or B200, I guess. Then what amount of work you need to put into that to do it, or it's just simple, you just swap the model?
Yeah, I think it depends. So um, there are different considerations. I think the Blackwell machinery has a new philosophy around the matrix multiply. So maybe the things that are most different is where and when registers are involved. So as you may know, like there's a lot of different kinds of memory on the GPU. There's like global memory, shared memory, register memory, and now in the Blackwell idiom, there's this tensor memory, which you can think of like kind of a register, but it doesn't have the infinite flexibility of the other registers, which means that it can be a little bit more optimized for specifically for matmuls. And so on Hopper, the actual WGMMA or WIGMA instruction leaves the data in registers when it comes out of the instruction. So that creates register pressure already, and then everything else that you do in the epilogue or whatever is still in the registers. But on Blackwell, it does not. The matrix multiply operation does not involve registers at all. So you don't actually have to bring it into registers afterwards if you don't want to. So there's less register pressure there. So you can actually potentially do more. You don't have to, maybe you could say you don't have to be quite as careful about registers in Blackwell, but you do, but you can probably have more of a budget in that way because you're not using them just by default anytime you want to do a matrix multiplication.
Yeah, like it seems like you need to have a deep understanding of the architecture first, even before writing like the most optimized thing.
Yeah, and there's more synchronization. Even Hopper introduced the need of like more of these things are becoming asynchronous. So the TMA, which is like moving data from the global to the shared, is always asynchronous. That's Hopper and Blackwell, and the tensor core operations are all asynchronous now. So yeah, it's changing the way that the programmer has to think, because like you have to be managing these asynchronous processes with like semaphores, basically like barriers.
What's your thought on like different tensor of chips like TPUs and Grok language processing unit as they call it?
Yeah, I haven't worked a lot with TPUs or the Grok stuff, but yeah, have you?
No, like, but I have explored the LPU they call it. Before they were calling it something else, but they give it a catchy name. So they had like 256 MB limitation on every like chip.
Mm-hmm.
So they require like huge amount of chip to run a model. Like let's say I can fit in a 16 GB model in a, let's say, 84 gigs of GPU, but I have to like divide it by 256 megabytes, and then I need to have that many number of LPUs. So it's, and also it takes harder to port a model into that. That's why you will see that catalog is not that much. They provide a limited set of models, but the inference is so fast, like it's around 1000 tokens per second for Llama
Oh,
3.2, I guess. You just blink of an eye, you get an essay in front of you, and that was very fascinating for me. Actually, one of the founders of Grok was the one who worked in the TPU in Google. Like he was one of the
yes,
founding engineers. Yeah,
Jonathan Ross, was it Jonathan?
yeah. Like there are co-founders also, but one of the guy was in the founding team of the TPU in Google. Yeah,
Interesting.
yeah. I don't know. They're not that much mainstream yet. Do you feel so?
Yeah, it seems that way. It seems like the NVIDIA hardware is still the clear winner at this point. And certainly Grok, I think, is kind of on the side. But yeah, I don't know. I'm hopeful that people will keep making progress, and NVIDIA will have some good competitors in the ecosystem.
I also came across this interesting startup called Etched, etched.com,
Oh
I
yeah.
guess.
I don't know
So
them.
what that company was doing was it was trying to bond the transformer architecture into the silicon itself, and that was so interesting to me.
Oh wow.
I I don't know how like practical that is, like whether it will get adopted or not, but that was a very interesting idea. Like they also raised funding recently.
Yeah,
Yeah, you can
that's
check
not.
that out. That's very interesting.
Yeah,
Yeah,
that's cool. I wonder how far that will go. That sounds cool.
I send you the name of the company. You can Google.
Okay.
Yeah. So any, yeah, the Google stuff.
The world's first transformer ASIC.
Yeah, that's the one.
Wow, looks interesting. Cool. Yeah. So what else would you like to ask about?
Yeah, so I also read about the argument that the performance optimization you gain by making the chip very specific to a task is very hard to overpower the general optimizations the NVIDIA does in a general GPU. Like,
That's cool. Yeah,
yeah,
they've really done a good job of maintaining a lead. Um, that's pretty impressive.
yeah. What kind of technical books you are reading these days, or any of your favorite technical books?
Oh, technical books. Wow.
Yeah.
Okay. I mean, I have a lot of math books that are great. Recently, I've been reading some of the textbooks by Terence Tao. Um,
Wow.
so great. I mean, he's obviously a great mathematician, but he's a great writer too. Um, and let's see, I'm just looking at my bookshelf here. Um, yeah, his book on Tao's book on random matrices is very good. And there's a combinatorics book I'm reading called Combinatorics: The Art of Counting by Sagan. I'm making my way through that one slowly. I think it looks very good. There's a book called Geometry and Physics, which I'm by a person named Jost, and I'm reading that because I know enough. I know like the math that I would need to know in order to learn physics, but I never really learned modern physics that much. So this is like a physics book for mathematicians, just like a quick speed run through the parts that you don't have to go and learn all the math because you know it. So I'm looking forward to getting further into that.
Just curious, Arik, like how you take out time to do all these things.
I
Read history books, read math books, work in
just
research.
go
So,
slow. I've probably been reading that book for over 2 years now. Just like whenever
okay.
I get a chance, I pull it down and
What's your typical day looks like? Like you are just into
yeah,
this, yeah.
I'll just open up the laptop and start have a cup of coffee and start coding, reading code, trying to understand it, and keep going. And when I'm finally, I swim every morning. I go
Wow,
swim.
that's great.
That keeps my good for my mental health just to get that out of the way. And then when I'm ready to take a break, I drive down to the beach and read a book for a little while, and then come back and do some more coding.
Do you use Cursor, by the way?
Do I use what?
Cursor,
Cursor?
ID?
Oh yeah, I use VS Code, but I haven't been using Cursor too much. I definitely use Claude Code. Claude Code I use all the time, every day.
I thought everyone in Silicon Valley is using Cursor. That's so much trending these days. But I
I think some
personally
people do.
don't feel much difference between VS Code Copilot and Cursor.
Yeah,
Personally, yeah.
I was not a big Cursor or a Copilot user. I don't know why, but it just never really appealed to me. But Claude Code for sure is great.
Yeah. So yeah, that's all I
Great.
wanted to ask.
Yeah,
I
well, let's
hope
keep in
we'll,
touch and
yeah, keep in touch.
get you going on your journey.
Yeah. Thanks, Eric, for making it happen. I
Yeah,
hope
it's my
so.
pleasure. And
Yeah,
we
glad.
can talk it again. I'm glad
Yeah.
to talk with you. All
Thanks,
right, thank you
Eric.
very much.
Bye.
Bye.